Hello, all my JavaScript friends. This is TheVirtuoid, aka Mike Smith, and this is our snake game. Okay, so I promised you that we're going to get to some code, and we're now going to get to some code. The first thing I want to do here is the vector. Now, if you remember in our very first video here where I had a nice, pretty little PowerPoint presentation, I told you all about how I'm going to use vectors to be able to determine the position of a particular object on the screen, like the header or a segment, the direction it's going to go, or the dimensions of a particular object, let's say the pitch, something like that. So now let's get a look into the vectors. And the idea here now is I'm going to create a base vector system. Let's bring up the design document. As I told you in the last video, every single object has its own design document. So let's bring up this design document. And so the vector base class is basically as it is our base class. Each one of the other vector classes, a 2D class, a 3D class, and a 4D class, will extend off of this. But I want you to see this one particular note here. It says, note, this is an abstract class. All methods will throw an exception if not implemented in a derived class. Why am I doing that? Well, first of all, let's go back. What is an abstract class? Well, an abstract class basically is a class that cannot be instantiated, but serves as a blueprint for other classes that extends it. And the idea here is basically that a vector, when I'm saying I'm going to be working with vectors, whether it's a 2D vector, a 3D vector, a 4D vector, I want all of my vectors to have an add method, for example, to add two vectors together. I want one to have a subtract method to subtract two methods. I want one to have a clone method, so you can clone a particular vector. Whether you set two vector or compare two vectors to whether they equal each other, to string, and so on and so forth. Multiply, compare to, inbounds, is inside, is perimeter, fill, opposite, random, plus some static ones for that's very convenient for directions where you got 0, up, down, left, right, forward, backward, fill, random, doesn't really matter. The base class itself is what defines all of these particular methods. And I'm basically saying that if you're going to implement a 2D vector or a 3D vector or a 4D vector or a 5D vector or a 20D vector, you're going to need to implement each and every single one of these. But the base class itself doesn't. Why is that? Well, the base class doesn't know what dimensions you're working with. Remember, we're going to say we're going to have a two-dimensional snake game. We're going to have a three-dimensional snake game, and we're going to have a four-dimensional snake game. How can the vector know whether, okay, I've got 3 dimensions, I got 2 dimensions, I got 4 dimensions, we need to work with this. No. We don't do it that way. We basically say, the base says, okay, all you other vectors, you need to give me an add, a subtract, a clone, and equals. I don't care how you do it. You just got to have these particular methods. And that's the whole beauty of an abstract class. An abstract class is our blueprint. I am saying that if you are to become a vector that extends this vector class, you need to implement all these methods. So the base class itself, if we go into the code, the base class itself throws nothing but errors. Because again, it has absolutely no clue whatsoever whether you're in a 2D environment, 3D environment, 4D environment, or 20D environment. It doesn't really matter. But again, I have this in here so that when a 2D file, which we'll show you the 2D file here in just a second, implements it, it will throw an error if it has not implemented a particular method. So for example, if we go to the 2D one now, here's our design for the 2D one. As you can tell here, 2D has two different properties, an X property and a Y property, because we're in a 2D environment. Methods, C vector for supported vector methods. I don't have to type those all again within the vector 2D. Its job is to implement everything that you see right here, or actually right here. Its job is to implement each and every single one of these using X and Y. So if a program sits there and says, I'm going to get myself a new 2D, it knows it's always going to have an X and Y. But more importantly, it also knows that if it says, I have a vector here, I'm going to add, whether it's a 2D, 3D, or 4D, it doesn't really matter because it knows it's going to add two 2Ds together if it's calling it from a 2D vector. So, my vector 2D.js has those. So basically, how do I do a compare to if I have an X and a Y? How do I do an inbounds if I have an X and how do I do an inbounds if I have an X and a Y? Or how do I do an add vector, an add if I had an X and a Y? How do I have a multiply if I have an X and a Y? Again, by doing that, I am now able to sit there and say, My 2D has got 2 properties. My 3D, when I get it done, so will have 3 properties. My 4D will have 4 properties. My 5D will have 5 properties. My 20D will have 20 properties. But it doesn't matter. Everybody's going to have an add, everybody's going to have a multiply, and everybody's going to have a subtract. And what that allows me to do is, let's say again, let's go into the head, for example. If I go into the head in the JavaScript file for the head's going to have a position, and it's going to have a direction. There's the position and direction. All I'm saying here is that if it's an instance of vector, if it's not an instance vector, I'm going to throw a particular error here. Is it an instance of 2D vector? No. Well, it could be, or it could be a 3D, 4D, or 20D. It doesn't matter, but it will always be an instance of a 3D vector. But the key here is if I want to get a position, or if I want to get the position, I want to clone the position, I just call clone. I just call clone there too. Let's see if we got another example. I think I got another example in here. There's 2 more clones. Yep, here's the add position where I'm getting projected position. So this allows me to be able to now say vector add. If this is a 2D environment, great, it's going to add X and Y. If it's a 3D environment, it's going to add X, Y, and Z. If it's a 4D environment, it's going to add X, Y, Z, and A. If it's going to be a 20D environment, I don't know what it's going to be, but it will do 20D. But that's the beauty of using this abstract class, is I can treat everything here as a vector. But how it is implemented is completely dependent upon how it's originally initialized by the game, because the game is going to sit there and say, oh, I'm going to use a 2D environment, a 3D environment, a 4D environment. And that's the beauty of all of this. The big responsibility is that each of these vectors needs to be able to implement each one of these particular methods. And if I happen to get a new method, then all I got to do is go in here to the vector.design, pop that new method in here to make sure I'm documenting everything. Go into wrong one. Go into my unit test on my vector for the unit test and say, hey, if I can do a compare to, if I do the new one, make sure it throws the exception. And then within my unit test of the 2D, make sure I take into account, like, it should return NN if I do a fill. So that's the beauty of having this abstract. And that's going to be the core key to understanding how this game works. Vector is going to be our saving grace for getting this program up and running. And that's really all there is to using the vector and the vector 2D, and in the future, the vector 3D, 4D, or even 20D. Thanks for watching. Subscribe to this channel to view more videos. Click on the like button on this video and visit us at TheVirtuoid.com. Also, support us on Patreon, where you can get access to member-only videos. Links are down below. Again, thank you very much for watching, and keep on coding.